Hello viewers, my name is Mr.Adebanjo. Welcome to my video. In this video we are going to be solving together this solid shape. We're going to be solving together this solid shape in this video, and this as a result of a student who need explanation on how to go about the solution of this solid shape. In previous videos you have been solving some composite shape and solid shape, and we have been seeing how we could solve composite shape when it comes to mensuration of solid shapes. We have solved a cylinder mounted upon cone mounted upon cylinders. We have solved the hemisphere mounted upon cone. We have also solved when an hemisphere is mounted upon cylinder as well, and then when a cone is mounted upon hemisphere. So if you want to check those videos, you might try to check the playlist of this video in order to lay your hands on those videos. So in this video I showed that the diagram is a portion of a right circular cylinder of radius 7 cm and a height of 15 cm. The center of the base of the cylinder is Q, while that of the top is B, where angle ABC, the angle here is equals to angle PQR, the angle here, and that is 120 degrees. You have to calculate correct to 1 decimal place the volume of this solid, and you also to calculate the total surface area of the solid as well. We have to take pi to be 22/7. So of course it shows that the structure we are having here is a solid shape, and we have been told that it's a right circular cylinder. That is, this is a cylinder, but it is not a complete cylinder. So something has been cut off out of the cylinder to give us this structure. Of course I believe that my viewer right now, I know that you know what a cylinder is all about. So that means something has been cut, the part of the cylinder has been cut off to give us this structure. So the question is, how do we find the volume of this structure, and how do we find the total surface area of the structure? So I want you to understand one thing before we find the volume of the structure, that this is a cylinder and a part of the cylinder has been cut off. Then when we know the part of the cylinder that has been cut off, or we know the leftover of the cylinder, then we will know how to go about the solution of it. Of course, we know that when it comes to a cylinder will have a circular top and you also have a circular base. So a cylinder has a circular top and a circular base for a cylinder. So that means the part of the top has been cut off, part of the circular top has been cut away, from here to here has been cut off. Also part of the circular base has been cut off also, and we know that the top and the bottom are equal. So part of the top has been cut off and the part of the bottom has been cut off. So we are given the angle of the top of the part of the top that is being cut off. So the part of this top the part of the circular top that has been cut off, we know the angle we know its angle, which is 120 degrees. So that means you can know the remaining angle of the circular top. So if this part of the circle that is cut off, the angle there is 120 degrees, so it means that we can also find the remaining angle for the leftover of the circular top. Of course, we know that the circular top here is also a sector, because this is a radius, another radius, so that's a radii plus this arc, that's form a sector. So but we know that this sector is part of the circular top, so this sector is formed by cutting off part of the circle. So if you can know the leftover of the circle, the angle of the leftover of this circular top, that is, if you can find the angle, that is this reflex angle of angle ABC, if you can find it, I mean this angle from here to here, if you can find it, then that will enable us to find the the leftover of this cylinder, and that will enable us to know the leftover of this circular top and how to find the volume. So how do we find the remaining angle of this circular top, since we know that from here to here is 120 degrees? So we know that the angle at a point, or the total angle in a circle, is 360 degrees. So that means this angle here will be 360 minus 120. So that means angle ABC, the angle here reflex, is going to be 360 minus 120, and that should give us a 240 degrees. So therefore, having known that this sector, the remaining part of the circle, which is a sector, we are having here the remaining part of this circle, which is a sector, we know the angle is it has is 240 degrees. So that means if you want to find the volume of this structure, that should be the cross-sectional area of this sector multiplied by the height. Of course, we know that the volume of a solid is the cross-sectional area of the solid multiplied by the height. So technically, to find the volume of this structure, we need to find the area of the cross-section, which is this sector multiplied by the height. So therefore, the volume of the solid will be area of the sector, that is this sector, whether the base or the top, anyone you want to pick out of the two. So multiplied by the height will give us the volume of this structure. And to find the volume area of this sector, we know that the angle of this sector is 240 divided by 360 times pi r square. So that will give us the area of this sector multiplied by the height of the solid. So, and the height of the solid is 15. But if you reduce this angle by I think 12 can 0 can cancel 0, 12 can go in 24, 12 can go in 36. So that will give us a 2/3. That will give us a 2/3. So that means even from this here, I can say that the whole diagram here is a 2/3 of a cylinder. The whole diagram you are seeing here is a 2/3 out of a cylinder. So that's another way you can see the question. From this this angle helps us to deduce that everything you are seeing here is a 2/3 out of a cylinder. Do you understand that? So from there, to find the volume, we have a 2/3 times pi r square h. Of course, we know that the total volume of a full cylinder is pi r square h. That's the volume of a full cylinder is pi r square h. Now this is a 2/3 of a whole cylinder, so that will give us a 2/3 pi r square h. So from there, if you substitute our values, pi is 20/7 multiplied by the radius of the circular top is 7, so you have 7 square multiplied by 15. So from there, if you simplify further, 7 will take care of 7 here, we have 7 left, so you have 2/3 times 22 times 7 times 15. If you simplify that further, we have 1540 centimeter cube as the volume of this solid, which is the 2/3 of a full cylinder. And what helps us to know that this is 2/3 of a full cylinder is the angle of this remaining sector, which is 240/360, and that enables us to know that this is a 2/3 of a full cylinder. So let's try to find the total surface area of the structure. Now, to find total surface area of the structure, we know that we need to find all the area of the surface of this structure. The first one you can see is the area of the top, which is the sector. Then we need to find the area of the base, which also is sector. We also need to find the area of the curved surface area of this we need to find the curved surface area of this 2/3 of the cylinder, because we know that we want to find the total surface area of a full cylinder. It will be curved surface area plus the area of the top, and that of the bottom if the cylinder is an open end cylinder. But in this case now, to find total surface area of the cylinder will be to find total surface area of this structure will be the area of the top plus the area of the bottom. We know that the area of the top and the bottom are the same thing, because this is a sector and this also a sector under. then plus the curved surface area of this 2/3 of the cylinder. Then we also have a rectangle here. We have a rectangle ABPQ, plus another rectangle here also, which is BCQR. So therefore, to find the total surface area of the structure, we have a area of the top sector, which is this one, plus area of the bottom sector, which is this, because we cannot see very well. If you want to see that, you have this something you are having at what you're having at the top is also at the bottom as well. So if you complete this, you'll be having this this arc here as well, plus this radii. So that will give us the area of the bottom as well, area of the bottom sector, then plus the curved surface area of the cylinder, then plus the area of the rectangle ABPQ, plus the area of the rectangle BCQR. So adding all this together will give us total surface area of the structure. So let's find the total surface area, the area of the top, which is the area of the sector here. We have already calculated it down before. That gives us a 2/3 pi r square. So that will give us the area of this sector, because the angle of the sector here is 240. So 240 divided by 360 times pi r square will give us the area of that top sector, and it's still the same thing as the area of the bottom sector as well. So that's why we are multiplying this 2/3 pi r square by 2. That will cover for the top and the bottom of the cylinder. Then plus the curved surface area of the cylinder is 2 pi r h. The curved surface area of a whole cylinder, of a full cylinder, is 2 pi r h. But this cylinder is the 2/3 of a whole cylinder. That's why we are having 2/3 times 2 pi r h. So this 2/3 is saying that this structure is the 2/3 of the whole cylinder. So that we are multiplying this curved surface area of the cylinder by 2/3, then plus the area of the rectangle, plus the area of the rectangle as well. Then that's why you're having length times breadth plus length times breadth here. Then from there, if you simplify that further, we have that we have 2/3. So LB plus LB will give us 2LB here, and also 2 times 2 will give us 4/3. Then 2 times 2 also will give us 4/3 here. So technically 4/3 is common to this and this, so you can factorize 4/3 pi r out of this and this. So if I factorize 4/3 pi r, so 4/3 pi r, so that means we have left here with r, then plus we will left here with h, then plus 2lb. From there we can substitute the values. We have 4/3 times pi is 20/7 times radius, which is 7 into 7 plus 15, plus 2 times the length is 15 multiplied by the breadth, which is the radius, which is 7. From there, if you simplify further, we have that 7 will take care of 7 here. So we have 4/3 times 22, then times 7 plus 15 is 22 also, plus 2 times 15 times 7 will give us 110. If you simplify that further, we have 855.33 centimeters square as the total surface area of this structure. So I want to believe that you really understand what you have done in this video. So if you do, please click the subscribe button if you are yet to subscribe to this channel, and we'll see you in the next video. Thank you. Bye.